Hi everybody, and welcome to Unit 4 in Honors Chemistry. So the focus of this unit is on the mole. And when we talk about a mole in chemistry, we are not talking about the furry little rodent. Instead, we're talking about a method in which that we use to count. All right. In chemistry, we're interested in atoms and when atoms and ions combine to form compounds. Those particles are incredibly small and really impossible for us to count. So what we need to do is to be able to figure out a way that we can figure out the number of atoms that we're dealing with, but not directly count them. Okay, so what we have done is developed a unit that is known as the mole. But before we talk about the mole, let's talk about a unit that we're very familiar with, and that is a dozen. All right, if I say you have a dozen eggs, well, that means that you have 12 eggs. The amount of a dozen is always the same. It's 12. Okay, if I were to ask you what the mass of a dozen is, well, then you should say to me, you know what, it's a dozen of what? If I'm talking about a dozen eggs, that's going to have a certain mass. If I'm talking about a dozen pencils, that's going to have a different mass. So the mass really depends. All right. A mole is the same exact idea. All right. Our unit is a mole that we care about. Now, instead of a number like 12, that's actually very easy for us to kind of visualize and certainly easy for us to count, a mole is a really large number. And that's because we're dealing with really, really tiny things. So a mole is 6.02 times 10 to the 23rd things. That's how many things that we are dealing with. This number is actually called Avogadro's number. All right. And it is a number that we use all of the time. So that's a number you really want to memorize. All right. Just so you know, Mole Day, there is a thing called Mole Day. And as you can guess, it is in October. It is October 23rd is the official Mole Day. All right. So the amount of a mole is 6.02 times 10 to the 23rd things. The mass of a mole, well, again, that's going to depend on what we're talking about. All right. Okay, so unlike with a dozen, where we really talk about dozens of lots of different things, when we're referring to a mole, the things we're dealing with, those 6.02 times 10 to the 23rd things, are really rather specific. All right, so the things or the labels that you're going to be using with Avogadro's number, okay, are going to be atoms or ions. Okay, remember atoms are neutral, ions have a charge. They could be molecules, and we use the word molecule if we're talking about a covalent compound. All right. They could be formula units. We use the term formula units when we're talking about an ionic, okay, compound. All right, so let's talk about how we're going to use this, okay? So let's do some examples together. How many atoms of sodium are in 3.5 moles of sodium? All right, well, we're back to factor label. We are going to be using factor label, and you need to use that all of the time. So what are we looking for? We're looking for atoms of sodium. What are we starting with? We're starting with 3.5 moles. The abbreviation for moles, M-O-L-E, is M-O-L, so you can drop the E, of sodium. Always a good idea to write what you're actually dealing with. All right, it's going to keep things organized as we move on. Well, atoms are things, okay? In 1 mole, how many things do you have? You have 6.02 times 10 to the 23rd atoms. All right, your moles divide out. You're left with atoms of sodium. That's what we're looking for, okay? If you punch that into your calculator, you're going to find that you get 2.1 times 10 to the 24th, okay, as your answer. All right, why don't you go on ahead and pause the video and give number 2 a try on your own. All right, so number 2 is the opposite of number 1. Now we're looking for moles, all right, of sodium. You're starting with 3.5 times 10 to the 27th atoms. Okay, so I want to get rid of atoms, and it is atoms of sodium. I want to get rid of atoms, so they're going to go in the bottom. I am going to go to moles of sodium, so they're going to go in the top. Remember, 1 mole has 6.02 times 10 to the 23rd atoms in it, okay? So your atoms have now divided out. You're left with moles. That's what you're looking for. You're going to go ahead, 3.5 times 10 to the 27th times 1, all right, divided by 6.02 times 10 to the 23rd. Always a good idea to practice putting those exponents into your calculator, okay? And you end up getting about 5,800 moles, okay? Or you can certainly write that 5.8 times 10 to the 3rd moles of sodium. Either one would be great, okay? All right, so, well, this is nice. We can go for moles to atoms or ions or molecules, but that still doesn't give us like a really practical thing that we can do in a lab. So here's our next big concept, and we're going to be using this all the time. And this is what's known as molar mass. This is the mass in grams of 1 mole of a substance, okay? Molar mass is equal to the mass from the periodic table, all right? But instead of AMUs, we're now talking about grams, okay? So let's see what this is gonna look like, okay? So 1 mole of sodium, okay? If you look on the periodic table for sodium, here's our nice little periodic table, Na is right there. Our mass of sodium is 23.0. 1 mole of sodium is 23.0 grams. Okay. How many atoms is that? That's 6.02 times 10 to the 23rd atoms. All right, because I'm dealing with 1 mole will always be 6.02 times 10 to the 23rd things. What's the mass? Well, it depends. We're talking about sodium, so the mass is the mass of sodium from the periodic table. All right, let's do the same thing for carbon, for sodium chloride, and for carbon dioxide. Go on ahead and take a moment, write those in, and see what you get for each of those. All right, so we're gonna look at the periodic table. The mass of carbon on the periodic table is 12. All right, so 1 mole of carbon has a mass of 12.0 grams, okay? That is 6.02 times 10 to the 23rd atoms, just like it was for sodium, because we're still dealing with 1 mole, okay? All right, so for sodium chloride, well, sodium chloride, I'm gonna add up the mass of 1 sodium and 1 chloride, and I get the mass to be 58.5 grams. And how many things? Well, now this is an ionic compound, so this would be 6.02 times 10 to the 23rd, in this case, formula units. All right. You can abbreviate this. It's an unfortunate abbreviation, but you certainly can if you would like to. All right, carbon dioxide. So the mass of 2 oxygens plus 1 carbon is 44.0 grams. So that is the molar mass of carbon dioxide. Well, that is 6.02 times 10 to the 23rd. And this is a covalent compound, so it is molecules. Okay, so if you notice, every time we have 1 mole, it is the same number of things. The type of things can certainly change. You can talk about atoms, ions, formula units, or molecules. What will change, however, is the actual mass in grams. All right, so let's go ahead and see how this looks in a problem. How many atoms of copper are in 25.2 grams of copper? So what am I looking for? I am looking for atoms of copper. I am starting with 25.2 grams of copper. All right, I'm going to use factor label to come up with my answer. So I don't want grams anymore. Grams are going to go on the bottom. You're always going to be going to the mole. The unit is called the mole. You will be using mole in every problem. So in 1 mole of carbon, where am I going to look to find the grams? I'm sorry, not carbon, copper. Where am I going to look? I am going to look on the periodic table and I see copper. The mass of copper is about 63.5. All right, 63.5. Great. Well, my grams have divided out. I'm at moles of copper. I don't want moles of copper. I need atoms of copper. In 1 mole of anything, you've got 6. All right, so we have the mass of copper, 63.5, and we got that from the periodic table. Now, I have converted from grams of copper to moles of copper. I'm now going to go from moles to atoms of copper, which is what I'm looking for. So moles of copper are going to go on the bottom. So they divide out. Atoms of copper are going to go on the top. In 1 mole, okay, there are 6.02 times 10 to the 23rd atoms. All right. Remember, a mole is like a dozen. A dozen, you always know there's 12 of them. When it comes to a mole, there's 6.02 times 10 to the 23rd of them. All right, and one of those things we talk about are atoms. Okay, we're going to go ahead and multiply 25.2 times 6.02 times 10 to the 23rd divided by 63.5, and you should get about 2.39 times 10 to the 23rd atoms of copper. All right, you want to make sure that you're practicing putting those exponents in your calculator, so that's something that you get very good at. Okay, let's do one more together. All right, and let's look at our next example. Okay, all right, so what is the mass? Now, anytime I'm asking for mass, all right, that's going to be a mass in grams. So what is the mass in grams of 4.75 times 10 to the 25th molecules of water? All right, so we're looking for grams of water. We're starting out with 4.75 times 10 to the 25th molecules of water. All right, there's no real good abbreviation for molecules because it could look like moles, so just stick with molecules. All right, well, in 1 mole, remember, we always go to the mole, there are 6.02 times 10 to the 23rd molecules. Now I want to go from moles to grams. So I'm going to put grams on top, moles on bottom. In 1 mole of water, you have 18.0 grams. And again, I got that 18.0 from the periodic table. That is the molar mass, all right, of water. Okay, you're going to multiply everything on the top, divided by 6.02 times 10 to the 23rd, and you should get about 1,420 grams. All right, why don't you go on ahead and pause the video now, and you can do 3 and 4. Okay, so let's take a look at 3 and 4. Okay, you can go ahead and take a moment to check those answers out. All right, what is the mass? Again, remembering that we're looking for that in grams, of 3.67 times 10 to the 24th molecules of silicon dioxide. Okay, so I changed from my molecules to moles. I went from moles to grams. 60.1 I got from the periodic table. When you find your answer, it should be about 366. Okay. Number 4, how many formula units? Remember, formula units is just the term we use for ionic compounds. Of aluminum carbonate are in 55 grams of aluminum carbonate. So I'm going to start with my grams of aluminum carbonate. I changed to moles using the mass from the periodic table. I changed to formula units using Avogadro's number. All right. And you should end up with about 1.41 times 10 to the 23rd formula units. It's an unfortunate abbreviation, but it's fine, of aluminum carbonate. Okay, fantastic. So now we are going to move on, all right, to some what we call our tougher mole problems. All right, and this is going to introduce a concept known as mole-to-mole ratios. We are going to be using these a whole lot, all right, in the coming months. You use a mole to mole ratio anytime you're going from one substance to another. So if you start by talking about a certain molecule and end talking about a specific atom, you're going to need to use a mole to mole ratio. For now, we're going to get our mole to mole ratios from the chemical formula itself. So let's look at an example. If I look at NH3, we know that's ammonia. Okay. For every one ammonia, you have one nitrogen and three hydrogens. Fine, very straightforward. It's the same idea if I'm talking about 1 mole. If I have 1 mole of NH3, well, again, for every one NH3, you have 1 mole of nitrogen and you have 3 moles of hydrogen. All right, so let's see how we're going to use that in a problem. All right, so how many atoms of carbon are in 25 grams of C3H8? C3H8 is actually propane, all right, like the propane tanks you might have attached to your grills. Okay, so how many atoms of carbon? That's going to be the label of our answer. Okay, and we're starting with 25 grams of C3H8. Well, remember, the first thing we must do is convert to moles. Everything in this unit is linked to the mole. So I'm going to change my grams of C3H8 to moles. So I'm going to put grams on the bottom, C3H8, there you go. Moles on the top. In 1 mole, all right, you have 44.0 grams, and we got that number from the periodic table. Okay. Here is our new step. I don't want my answer to be in terms of propane. I want just those carbon atoms inside. So what I'm going to do is set up a mole to mole ratio. So I'm going to put moles of my whole compound in the bottom. That's because that's what I have over here. Then just moles of what I'm looking for on the top. Well, if I look at C3H8, for every one C3H8, for every 1 propane, I have 3 carbons. So it's the same thing. For every 1 mole, I have 3 moles of carbon. Okay, great. Well, now I'm going to change from those moles to atoms just like we did before. In 1 mole of anything, you have 6.02 times 10 to the 23rd of those things. Okay. You're going to go on ahead and punch that in your calculator. And you should get an answer of about 1.0 times 10 to the 24th atoms. All right, great. Okay. You feel free to go on ahead and try number 2, but I'm going to walk you through it as well, okay? How many sulfate ions, okay, are in 2.5 grams of aluminum sulfate? So your final answer is going to be in terms of sulfate ions. You can just write it like that, the polyatomic ion sulfate, or you could certainly write the word ions after it if you'd like to, but you don't necessarily have to. You're starting with 2.5 grams of the entire compound. Now, of course, we have to know how to write that compound out. Aluminum is +3, sulfate is -2, so that's going to be Al2SO4 3. All right, I'm going to change those to moles because that is what we do for every problem. And it's 342.3 grams. All right, and that's 1 mole of aluminum sulfate. Okay, got that from the periodic table. Here comes my mole to mole ratio. In 1 mole of my entire compound, I have 3 moles of sulfate. Okay, where did I get that from? I got that from the formula. Okay, I got the mole to mole ratio from the chemical formula. All right, well, now I'm going to change from my moles to ions. In 1 mole, remember, in 1 mole, how many are there? There's 6.02 times 10 to the 23rd. And this time we're talking about ions, okay? You're going to multiply everything on the top, divide it by 342, and you should get, all right, about 1.3 times 10 to the 22nd ions. All right, great. Now, a couple of things. Please make sure as you are doing this work that you are using the factor label method. All right, if you are solving this with using an X and setting up an algebraic problem, please, that's not going to be okay. It is going to be required that you use factor label. All right, so very, very important. You're going to have a lot of chance to practice this. Take care.